Hello, welcome to this wonderful lesson on long division. Now, long division is something that you probably have learned at one time, and now we're going to learn how to do it with polynomials. So, to start it off, assuming that my screen moves, wonderful. We have to remind ourselves exactly how this goes. Into 7. So first we're thinking about division. We divide 3 into whatever we can first, and it goes in twice. After we get the 2, we multiply it. So 3 times 2 is 6. After we multiply it, then our next step is subtraction. And then we bring down the next value that makes sense, in this case of 2. And then we start the whole process over using this number here. 3 goes into 12 4 times, and then we subtract to get 0. All right, that was a pretty basic one. Now let's do one that's a little bit more complicated. 41. How many times does 41 go into 163? Well, 40 goes into 160 4 times, but 4 times that would be 164. So let's do 3. So that would be 3 and 12. So now I have 40. And now we bring down our next value, which is 3. How many times does 41 go into 403? I'm going to guess 9. And that's 36. And now that turns to a 39. And that turns to 34. And so on and so on. And hopefully you understand where we're going from this. I don't want to spend a whole bunch of time on that. Now, this one I'm only showing to show that we don't skip these. What we do is we say 12 goes into 10. No, 12 goes into 100. Yes, what is that? 8 times, that would be 96. And then we drop down the 0. And then we keep going and so on all the way until we get to the end. That might make sense later. Now, if we have the same thing but in variables, we're going to do the same process. We're going to divide what we can, then we're going to multiply, and then we're going to subtract, bring down the next value that makes sense, and then repeat. So how many times does x go into 2x to the third? Well, that's going to be, we're going to need a 2, and then x squared. 2x squared times x equals 2x to the third. Perfect. So when I multiply it out, and now I multiply this times this to get 2x squared. Once I have these lined up, now my next thing is to subtract. So we subtract, that cancels these out, and I'm left with negative 1, because 1 minus 2 is negative 1, x squared. Once I subtract, I bring down the next value, and so it's minus 4x. Now what times x gives us negative x squared? Hopefully you're saying negative x. So when I multiply that, I get negative x squared minus x. After multiplication, we go to division or subtraction. So subtracting a negative is like adding. So now those result in 0. And so this one would be negative 3x. Drop this last one, minus 3. And so on. And this one works out wonderfully with a remainder 0. So what if I have a remainder of 0? What does that mean? It means that it is a factor. So we found out that x plus 1 is a factor. So x plus 1 times 2x squared minus x minus 3 is the result. Now we could continue to factor this, but this x minus 1 tells us that there's a 0 here. Once we factor this, we'll find out that it's actually a double zero, but that gives us some indication on what the graph is going to look like. All right, now we're going to try this. X goes into x to the third, x squared times, multiply it out, add it up, and now I have 3x squared minus 3x. I'm going to put 3x here. So I have 3x squared minus 12x. When I subtract, I change those signs. So I have 9x minus 36. And that goes in 9 times 9x minus 36, and it all will cancel out. And that's all nice and good. And so I know 4 is a 0 of this polynomial here. And I don't think that factors. But we could figure out what the other two zeros are by using uh, quadratic formula or solving for perfect squares. All right, now this one, I believe this is the last one I'm going to do of this type. If I have 2x, it goes into 8x cubed. That's going to be 4x squared times. And now when I subtract, I get 14x squared plus 9x. What times 2x is 14x squared? That would be 7x. And I have 14x squared plus 7x. Subtract it out. I have 2x plus 1. So I have a plus 1 there. And all of these have worked out wonderful. Now, when we graph these, we know that this one has a 0 at negative 1/2. So that would be the 0 right there. We could factor this value to find out what the other two zeros would be, here and here. Or if the factoring doesn't work, you'd have to use a quadratic formula. So this one, what happens when the remainder isn't 0? So let's all multiply this out real quick. We x squared 3x third minus 5x squared, subtract, and then this would be 4. And now when I do this, this would be negative 2, negative 6x plus 10. When I change the signs, this would be negative 4. Now, typically when we had a negative or a remainder, we would put that over this as a fraction, and that's exactly what we're going to do here. So we're going to do minus 4 over 3x minus 5. And so this is our answer here. So that means that 3x minus 5 doesn't divide unevenly, so there's not that's not a 0. All right. Now I think oh, the one thing I missed, if it doesn't have a term, each of the ones so far it went down 1 degree each time it went down. And if they're missing one, you just have to add in a plus 0 x squared. So you fill in that spot just like our example in the beginning. All right, hopefully you can do the homework now.